All right, so this is the answer key for graphing general rational functions. So let's go ahead and take a look at this here. So the first thing, it says for the following problems, find the asymptotes and sketch the graph of the equation. Okay, so first thing I notice is this an a value at the top. So we have a transformation, right? So the vertical asymptote is going to be setting the denominator equal to 0. So x minus 3 equals 0. So therefore x equals 3. And because it's a transformational one, I know this is my restriction against the domain. So for the domain, x cannot equal 3. For my horizontal asymptote, it's just positive 2. So y equals k. So in this case, y equals 2. My range restriction, y cannot equal positive 2 as well. For the RD, nothing can reduce at the top and the bottom. You can't cancel out any x's, so there is none. So when I graph this one, x equals 3, y equals 2. And then last, this a value is negative. So instead of being in quadrants 1 and 3, they're going to move to 2 and 4. And there's my graph. All right, for the next one, number 2, once again, we have a number at the top. So my vertical asymptote, we set the denominator equal to 0 and x equals negative 1. So therefore my domain is x cannot equal negative 1. For my horizontal asymptote, there is no k value. So that's a value of 0. So y equals 0. Therefore my range, y cannot equal 0. RD, since there's a number at the top, there's not going to be whatever. So hopefully that helps you out there. If you see a number at the top, there should be no no removable discontinuity. All right, for number 3. Now, for number 3, it's a little bit different because we see we have 2 x's now. So we're going to use the simple rules. For the vertical asymptote, we still set the denominator equal to 0, and that one's done, so x equals 0. And since this just has x to the first divided by x to the first, the domain is not the vertical asymptote, so x cannot equal 0. For the horizontal asymptote, we take the leading terms. They both have x to the first power, so we divide those. Y equals x divided by x, so y is equal to 1. So my range, y cannot equal 1. For my removable discontinuity, we have no common factors, so there is none here. So here we're going to graph this. Vertical asymptote is at x equals 0. Horizontal asymptote is y equals 1. And this is the one where we have to test the point, right? So I notice that 0 is being used, so I'm going to test the point at x equals 1. So we're going to plug it in here. 1 minus 2 over 1, which is negative 1 divided by 1, which is negative 1. So my point is 1 comma negative 1. So 1 comma negative 1. And we can see this is in the 4th quadrant, so therefore my other branch is going to be in the 2nd quadrant. Okay? I did forget to graph number 2, so let me show you that one real quick. So x equals negative 1. Y equals 0. So since, and it's a positive 3, so that's going to be quadrants 1 and 3. All right, let's keep going. So those are questions number 1 through 3 answered for y'all. Let's take a look at 4, 5, and 6. So 4, it's just like number 3. You have an x to the first power on the top, x to the first power on the bottom. So we're going to use the simple rational function rules. So first, for my vertical asymptote, set the denominator equal to 0. So x is equal to 4. So therefore your domain is x cannot equal 4. For your range, we take the leading terms, so x and x, so y equals x divided by x, which is 1. And therefore your restriction against the range is y cannot equal 1. Now for your RD, these x's cannot cancel out, right? Because this is x minus 1 is one factor, x minus 4 is another, so there are no common factors in the numerator and denominator. So your removable discontinuity is none. So I have a vertical asymptote at x equals 4. Horizontal asymptote at y equals 1. And I'm going to test the point to see if it's in quadrants 1 and 3 or 2 and 4. Okay, so let's go ahead and plug the value of 0 into there. So we're going to say x is equal to 0. So 0 minus 1 over 0 minus 4, which is negative 1 over negative 4. So my point is going to be 0 comma 1/4. That appears to be in the third quadrant. Therefore, your other branch is in quadrant 1. All right, let's go ahead and move on to question number 5. So for question number 5, it's just like this one. We have x to the first on the top and the bottom, x to the first on the top and the bottom. So vertical asymptote, we set the denominator equal to 0, so x equals -3. Therefore, your domain, x cannot equal -3. For your horizontal asymptote, we're going to divide the leading terms, 5x divided by x, which is 5. So y is equal to 5. And for my range, y cannot equal 5. For the RD, there's nothing I can factor out, so there's nothing to simplify. So my RD is none. All right, so x equals -3. 1, 2, -3. Y equals 5. 1, 2, 3, 4, 5. And we have a restriction. So here we're going to test where our branches are. So 0 wasn't being used, so I'm going to plug 0 into here. So 5 times 0 plus 2 over 0 plus 3, which is 2/3. So 0 and 2/3 falls right here. This is going to be in quadrant 4. So therefore the other branch has to be in quadrant 2. All right, for number 6. So this is where it finally becomes a little bit different. You're going to have to use all the rules here. So this is the graphing general functions. Okay, so the first step we're going to do, so this is where order does matter, right? These other ones, the order really didn't matter. This one does, okay? And it's because I have a quadratic function. I have x on the top, x on the bottom. Okay, so the first thing we're going to do, we're going to do our horizontal asymptote. That is step 1. So for our horizontal asymptote, we look, where is the highest power? Is it at the top, bottom, or are they the same? Well, in this case, I can see x squared is bigger than x. So the biggest power is on the bottom. So by default, the horizontal asymptote is y is equal to 0. Second, after we do horizontal asymptote, we're going to go to the domain. So for the domain, we're going to factor the denominator. It's going to factor out to x plus 5 times x minus 4. So therefore, your domain is x cannot equal. What value makes positive 5, 0? So -5 plus 5. And then 4 minus 4 is also 0. So my restrictions against the domain that cause the denominator to be 0 are -5 and positive 4. After you do the domain, you're going to do your removable discontinuity. So you're going to check to see if there's any common factors on the top and the bottom. So x plus 5 is already factored, so I'm going to put that at the top. And hopefully see that x plus 5s are common. So you cross those out. Then you take it over here, you set it equal to 0, and you solve. So x equals -5. That is the x value of the whole. So now what we're going to do is we're going to simplify this equation here. So there's nothing left on top, so it's a 1, and divided by x minus 4. So there is my simplified equation. To find the y value, all we simply do is we take -5, this x value, and plug it into this equation to solve for y. So 1 over -5 minus 4 is 1 over -9. So it appears that my hole is at the coordinates -5 and -1/9. Okay. Now for our vertical asymptote comes from the remaining denominator from our simplified equation. So right here. So we take x minus 4, set it equal to 0, and x equals 4. And last but not least, we have the range. So y cannot equal the horizontal asymptote, which is y equals 0, and it cannot equal -1/9 because that is the y value of the whole, and those are your restrictions against your range. So over here, there's a lot of stuff to graph. So x equals 4, so 1, 2, 3, 4. Y equals 0. -5, 1, 2, 3, 4, 5, and -1/9. So that's going to be a little hole right there. And that's it. So if we make our graph here, we can see that this one is going to be in quadrant 4. So therefore, your solution, or sorry, your other branch is going to be in quadrant 1. So 1 and 3. Sorry, 1 and 3. All right. So take a look at that there. And we're going to try another one that's very similar to this. Okay, so again, we have x on the top, x on the bottom. So there's only three things I'm asking you all for here, or four things, sorry. So the first thing we do always is a horizontal asymptote. So I can see that the highest degree is at the top, so x squared. Since that is the highest degree, that's going to be no horizontal asymptote, so I'm going to put the word none to represent that. After I do the horizontal asymptote, I go to the domain. So we're going to factor the denominator, which is already factored, so I don't have to worry about it. So what makes this 0 is x cannot equal, cannot be -3. All right, so step 3 is your removable discontinuity. So I'm going to factor the top, and what I notice is that I can factor out a 3, and that's going to give me x squared minus 9. And I can actually factor this again, right? Leave the 3 alone, and this becomes x plus 3 and x minus 3 over x plus 3. So hopefully when you look at this, you do see a common factor. In the numerator and denominator, we have x plus 3, so we cross those out. Right here, we set it equal to 0 and solve. So x equals -3. And now to get my y value, I'm going to rewrite this as a simplified equation. So there's a 3 times x minus 3 on the top. And there is no actual denominator. Okay, so that's different. We're going to distribute the 3. 3 times x is 3x. And 3 times -3 is -9. So there is no denominator, right? There's nothing at the bottom. So therefore, your vertical asymptote, step 4, is going to be none. All right. Okay, the last thing we'll do is we're going to graph this. Now this was a rational function. Now it's been reduced to a line that has a hole in it. And I forgot to figure out the hole, so we're going to do -3 in here. So 3 times -3 is -9. And -9 minus 9 is -18. So we have a hole in the graph at -3, -18. Okay, so I'm going to start at -9 for the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my slope tells me to go up 3, right 1. Right 1. And this should be up here. And we just draw our graph. But we know that at -3, -18, somewhere all the way down over here, there is a hole. And that's your graph. Okay. All right, for number 8. Once again, we have an x on the top, x squared on the bottom, so we have to use the rules for graphing general rational functions. So the first rule says, what is the horizontal asymptote? So the highest degree is at the bottom, so therefore automatically y is equal to 0. Now we're going to do our domain, and so we factor the denominator, so that's going to be x plus 7, x minus 7. So therefore my restrictions that make the denominator 0 are -7 and +7. So I'm going to put plus or minus 7 for y'all there. Next, we're going to do the removable discontinuity. So we're going to place this x plus 7 on the top. And I see I can cross out x plus 7 1 to 1. So we're going to write x plus 7 equal to 0. So x equals -7. That's the y value, or sorry, the x value of my vertex. Now I'm going to write this other equation in simplified form, which is going to be 1 over x minus 7. So now we take -7, this x value, and we plug it in here. So 1 over -7 minus 7 is -1 over 14. So my hole is at -7 and -1/14. And last, for my vertical asymptote, I look at my simplified equation. I set the remaining denominator equal to 0 and solve it. So for my vertical asymptote, x equals 7. So let's go ahead and graph this. 1, 2, 3, 4, 5, 6, 7. Y equals 0. And we have a hole at -7 and -1/14. So it's somewhere down here. Now, what a hole allows us to do is we don't actually need to test the point anymore to make sure it doesn't work. And also, I can use my simplified equation. A is +1, so they should be in quadrants 1 and 3, which is exactly where the graph is. So it's going to be in quadrants 1 and 3. All right, let's get down to these last few here. It says, given the following vertical and horizontal asymptotes, write the equation to match. Okay, so we're going, okay, so we're just going to write it. For me personally, I think the easiest thing to do with these is to use the transformation equation. And don't get confused, this A value, I usually just change it to a 1 so I don't have to worry about it. Vertical stretch, vertical compression, all that doesn't matter. The reflection doesn't change anything. I'm just trying to get this vertical asymptote and this horizontal asymptote. So y equals 1 over. So x equals 7. Pretty much I just need to subtract the 7 over, and that becomes x minus 7. And for y equals -3, the k value, that is what it is, so -3. Okay, we'll do the next one. Y equals 1 divided by, so over here, we add the 2 back over, x plus 2. And remember, that's left 2, this is left 2. And then for y equals 5, that's my k value, so plus 5. Okay, so you can see hopefully that it's not too difficult. Vertical asymptote is 9, so x minus 9. And my k value is going to be 0, so I don't have to put plus 0, I just leave it blank, and I'm done. Alright, for number 12, it says, given the following, write the new equation after each problem is translated 2 units left and 3 units up. Okay, so for this first one here, it has a number at the top, so there is no k value, so that's an easy fix. This is 0, right? So it's really just plus 0. So to make it go up 3, we can just add 3 here, and that's going to be y equals 3 divided by x plus 3 on the outside. So left 2. This currently goes left 2. If you want to go left more, so you're going to add 2 more, it's going to be plus 4. So originally it was left 2, and now it's left 4, which means it has been translated 2 more units additionally to the left. All right, for number 13, this one, if you recall, to find the, so 3 units up is affecting your horizontal asymptote. So x divided by x is 1. And now if I just plug in a 3 there, 3x divided by x is 3. So we have 3x divided by x minus 5. And it says it wants to go left 2 units. So currently this is going right 5. If I just add 2 units, that becomes minus 3, which is now left 3 units, right? Instead of being the other way around. Oh, sorry. This was, I was looking at the wrong one, I think. This is x plus 1, which is left 1. So if I add 2 more, that becomes x plus 3, which is left 3 as opposed to left 1. So it has moved 2 units additionally to the left. All right, and this last one is a little bit tricky. It says you have an x on the top and the bottom. So to make the 3 units up, remember your y-intercept comes from these two. So we're going to make the top one 3x. So y equals 3x over. Now, this x minus 2 currently means right 2 units. So what I'm going to do is I'm going to add 2 to this. So negative 2 plus 2 is 0. So we have an x on the top and the bottom, which hopefully you see this. Y equals 3x divided by x. We can actually simplify that to y is equal to 3, which is going to be a line that has a hole in it. Yeah, possibly. Yeah, so it just came out to y equals 3. All right, and that's the homework.